For thousands of years, humanity looked upward and believed the night sky was something orderly, almost complete. Ancient civilizations traced patterns among scattered stars, transforming distant lights into gods, hunters, beasts, and legends. To them, the heavens felt permanent, a celestial structure suspended above human existence with purpose and design. As centuries passed, mythology slowly gave way to observation. Astronomers mapped planetary motion with astonishing precision and discovered that the universe obeyed rules. Philosophers debated whether reality stretched forever or ended somewhere beyond imagination itself. And gradually, a powerful belief emerged. Perhaps the cosmos could eventually be understood. But history reveals a strange pattern. Every time humanity believes it has assembled a complete picture of reality, the universe changes the image entirely. The Earth was once thought to stand at the center of existence. Then we learned it orbited the Sun. Our galaxy once seemed to encompass everything. Then we discovered countless others beyond it. Even space itself, once imagined as static, was found to be expanding. Again and again, certainty gives way to larger questions. And now, it is happening once more. A machine built by human hands is peering farther into cosmic history than ever before. The James Webb Space Telescope is not simply a more powerful version of earlier observatories. It represents an entirely different way of seeing reality. Suspended deep in space, far beyond Earth, Webb unfolds a giant gold-coated mirror in darkness. Unlike ordinary telescopes, it was designed specifically to detect infrared light, ancient radiation stretched across billions of years by the expansion of the universe itself. Light emitted near the dawn of time no longer arrives looking the way it once did. During its journey across expanding space, its wavelengths stretch into infrared. Webb was built to capture those signals. In a very real sense, it is a machine designed to look backward through time. Before Webb, the Hubble Space Telescope had already transformed humanity's understanding of the cosmos. One of its most famous discoveries came from staring into what appeared to be a tiny, empty patch of darkness in space. The region was unbelievably small, equivalent to looking at a grain of sand held at arm's length. At first, there appeared to be almost nothing there. But after days of exposure, Hubble revealed a staggering truth. The darkness was crowded with galaxies. Thousands of them. Not stars. Entire galaxies, each containing billions of stars and potentially countless planets. That single image permanently changed human perspective because it revealed something extraordinary. Empty space was not empty at all. Yet even Hubble had limitations. The oldest light in the universe had shifted too deeply into infrared wavelengths for Hubble to fully observe. To witness the first chapters of cosmic history, something more powerful was necessary. That is why Webb was created. Scientists expected Webb to sharpen existing theories and provide greater precision. Instead, it delivered surprises almost immediately. Its first deep-field images revealed astonishing numbers of distant galaxies. Nearly every visible point of light seemed to contain entire systems of stars. But the greatest shock was not their quantity. It was their structure. According to prevailing cosmological models, galaxies in the early universe should have appeared small, chaotic, and unfinished. Matter should still have been slowly gathering itself together. Order was supposed to take time. But Webb revealed something unexpected. Some of the earliest galaxies appeared surprisingly massive, remarkably mature, and strangely organized. Structures that should not have fully formed yet already existed only a few 100 million years after the Big Bang. On cosmic timescales, that is an extraordinarily young universe. And yet, these galaxies already looked developed. Some even showed evidence of heavy elements like carbon and oxygen, materials forged inside stars. But for those elements to exist, multiple generations of stars must already have lived and died. How could that happen so quickly? Suddenly, astronomers faced an uncomfortable possibility. Perhaps stars formed faster in the early universe than expected. Perhaps galaxy growth happened more rapidly. Or perhaps, some part of our understanding remains incomplete. And that possibility is exactly what makes this moment so important. Because discovery often begins where expectations fail. And Webb may be revealing the beginning of another scientific revolution. But galaxies are only one piece of a much larger puzzle. Across unimaginable distances, matter in the universe is not randomly scattered. Instead, galaxies organize into an immense structure known as the cosmic web. Vast filaments of matter stretch across hundreds of millions of light years, connecting galaxy clusters like threads woven through darkness itself. Between them lie enormous cosmic voids, regions containing almost no matter at all. Together, these structures form one of the largest known architectures in existence. And much of it appears shaped by something humanity still cannot directly observe. Dark matter. Dark matter remains one of the greatest mysteries in modern physics. It emits no light. It cannot be seen directly. Yet its gravitational influence appears everywhere. Galaxies rotate too quickly to remain stable without additional hidden mass. Clusters behave as though invisible structures hold them together. Dark matter acts like a cosmic scaffold upon which galaxies assemble. But even dark matter may not fully explain what Webb is observing. Once again, the same question returns. Why does complexity appear so early? Why do some structures seem far more evolved than expected? The answer remains uncertain. And uncertainty in science often marks the beginning of progress. Because uncertainty forces new questions. It pushes theories beyond comfortable boundaries. But Webb is doing far more than studying ancient galaxies. It is also examining worlds orbiting distant stars. Using spectroscopy, Webb can analyze the atmospheres of exoplanets and detect chemical signatures such as water vapor, methane, carbon dioxide, and potentially other compounds associated with habitability. Think about the scale of that achievement. Humanity has built a machine capable of studying the chemistry of alien skies across interstellar distances. Worlds we may never physically visit are becoming places we can investigate scientifically. Every spectrum becomes a clue. Every signal becomes a question. And somewhere among those distant worlds may exist environments where chemistry crossed into biology. Perhaps that is why Webb feels different from previous instruments. It is not merely observing distant objects. It is changing humanity's relationship with the universe itself. Because every discovery reveals the same paradox. Reality is far larger than we imagined, and yet strangely understandable at the same time. On a small rocky planet orbiting an ordinary star, a species evolved capable of detecting photons emitted near the beginning of time. We can examine galaxy formation, study cosmic evolution, investigate alien atmospheres, and ask questions about existence itself. There is something deeply astonishing about that. Somewhere billions of years ago, ancient light began a journey across expanding space. It crossed oceans of darkness, survived the birth and death of stars, traveled through shifting cosmic structure, and finally arrived at a mirror crafted by human hands. There is something almost poetic in that encounter. Signals born near the beginning of time meeting minds capable of understanding them. Past and present connected across unimaginable distances. And perhaps the most profound realization is this: the story has barely begun. In the coming years, Webb may discover galaxies even older than those already observed. It may reveal how the first black holes formed. It may uncover unexpected chemistry in distant planetary atmospheres. It may answer questions humanity has carried for generations. Or create entirely new mysteries nobody has yet imagined. History demonstrates one thing with remarkable consistency. Whenever humanity builds a better way of looking into the cosmos, the universe responds with surprise. And right now, through a golden mirror drifting silently in darkness far beyond Earth, the universe is surprising us once again.